We are tasked with determining linear, quadratic, and exponential functions given a table. So we're being asked to determine linear, exponential, and quadratic. So remember linear, we wanted a constant value added or subtracted. Then for an exponential, we want a constant value multiplied. And for quadratic, what will happen will be a linear change. You'll see what that means here in a moment. So to start, we go to our y values and we see from -5 to -9, added 4. From -9 to -13, added 4. So we are on track. As long as it stays the same, and it does, they all add 4, that is a clue that that is a linear function. We'll move to function 2. We can see that there was a subtraction of 6, and then they subtracted a lot more. So we're not linear. We're not adding or subtracting the same value because it changes by quite a jump. So I'm going to think about what might they have multiplied. So -2, and then if we take that times 4, we're going to create 8. And if I take -8 times 4 again, we've created -32. And I'm going to check -32, again, times 4 will be 128. So our pattern is now exponential. We were multiplying by the same value. Because over here, all of these increase by 1. Again, function 3, all of our x values increase by 1. So now our task is to see if they're adding the same value or if we might have a linear change. And so when I go from 14 to 15, we added 1. 15 to 22, we added 7. 22 to 35, we must have added 13. From 35 to 54, we added 19. So that pattern right there is going to reveal to us if it's quadratic or not. So we're going to look at 1, 7, 13, and 19. So we're going to do a second difference. We're going to see if that second difference is constant, because remember, linear means there was a constant change. So when I go from 1 to 7, it added 6. From 7 to 13, it added 6. And from 13 to 19, it added 6. So now I know this answer is quadratic. Okay, second example here. So again, we're going to check for a constant change, a linear change, or a multiplication change. So when I analyze x, all increase by 1, then I go 15, 9, and then I go back to 15. And so I'm going to look for a difference because I'm not really multiplying. So 15 to 9, I had to minus 6. From 9 to 15, I had to add 6. Then from 15 to 33, we had to add goodness, 18. And then from 63 to 33, we must have added 30. So when I check for a second difference, we added 12 to go from -6 to +6. And did we add 12 again? And we did. 6 plus 12 is 18. And then 18 to 30 is, again, another 12. So 2 differences. The second one is constant. The first one's linear. So now I know I have a quadratic function. So we go to function 2. I see 3 times 4 might be 12, and times 4 again is 148. So we want to check if 48 times 4 is 192, and it is. So that is our pattern, times 4, times 4, times 4. And if you take 192 times 4, again, you get 768. So exponential, since we were multiplying. Function 3, we want to take and figure out what did we do to go from negative 63 to 42. And we added 21. And then from 42 to 27, we, negative 42 to negative 27, we added 15. From negative 27 to negative 18, we added 9. And then from negative 18 to negative 15, we added 3. So let's find out if this is a linear change. So we're going to find out, do we have a constant change between that first difference? So when I go from 15, I compare 21 to 15, I had to minus 6. And from 15 to 9, I had to minus 6. So now I have a second difference that is constant. So I have a quadratic. And that's how you determine if you have a linear, quadratic, or exponential function. So again, quadratic, you will have 2 changes. Exponential will have a multiplication, and a linear function will only have 1 change that is constant.